Dear friends, welcome to ACE Engineering Academy, ACE Online. Today, first of all, I wish you all the best for the RRB examination, because RRB examination will be giving us such a lucrative job in civil engineering. It is just like the highly lucrative job, just like a slogan, simply sitting, monthly getting. We don't sit ideally, but the nature of the job, the promotion, the salaries, the extra benefits we get in RRBs are fantastic. So, in this contest, on behalf of our ACE Online Academy, we wish you all the best. In the today's program, we are going to see the important questions in the two most important subjects. One is engineering hydrology, or दूसरा वाला second one is irrigation engineering. In engineering hydrology, if you see, in engineering hydrology, if you have time, you have to read each and every chapter. If your time has become a constraint for your serious preparation, then you have to give concentration on 4 chapters. First one is precipitation. Second one is evaporation. Third one is hydrographs. And fourth one, equally important for every RRB examination, it is groundwater hydrology, that is well hydraulics. Well hydraulics. Like this, if you concentrate on the 4 chapters, 80 to 90% of the questions you can get through. Any competitive examination, if you are crossing 70%, you are on the side of winning side. So, undoubtedly, definitely, if you are thorough with the practice of these 4 chapters, theory and questions, you can make yourself ensure that total engineering hydrology is covered. I am telling you, when there is a serious drawback of lesser time for your preparation. अगर ज़्यादा टाइम आपके पास उपलब्ध हो तो don't leave any single question, any single chapter. Both the subjects, both combinedly come under water resources engineering. Both engineering hydrology and irrigation engineering are very, very important. कृपया ध्यान से सुनिए. If you come to irrigation engineering, there also out of 12 chapters, you must be thorough, fully thorough with 4 chapters. First chapter, water requirement of crops. First chapter is water requirement of crops. Second chapter, design of unlined canals. Third chapter, diversion headworks, which in the loose sense we call it as weirs and barrages, and gravity dams. Here one point I want to stress to you, that here all 4 are equally important. Hydrographs is the most important one. In irrigation engineering, it is the topmost important. This is the second most important. This is the third most important. Equally important is these 2. Out of 4 chapters, there are 12 chapters available in irrigation engineering, as you know pretty well, including the percolation tanks and miscellaneous topics. Even though syllabus is given in a very wavery and vague format, depending upon the questions being given in the previous RRB examinations, the related topics you must and should prepare thoroughly. And water requirement of crops, don't forget any of the points. Unlined canals also, with somewhat less concentration, you can refer to diversion headworks and gravity dams. Don't forget to touch earthen dams also. कभी कभी earthen dams से भी एक क्वेश्चन पूछा जाता है, so you can answer very easily. Remember, those 4 chapters and these 4 chapters, total 8 chapters will make you self-sufficient to get through, to get selected for your job of engineer in RRB. With once again good luck. We see one by one chapter, what important points you have to, what important questions you have to see in the respective chapters. First we see precipitation. What is the average rainfall in India? Average annual rainfall in India, most commonly asked question, 119.4 centimeter. What is the most commonly used non-recording rain gauge? Non-recording rain gauge in India, most common non-recording type rain gauge, everyone knows Siemens rain gauge. Siemens rain gauge is the common one. Till recently, these days we are using Indian standard rain gauge, Indian standard non-recording rain gauge. Then most common recording type rain gauge. Recording type rain gauge. Here we have 3 aspects. IMD recommended, Indian Meteorological Department recommended siphon type rain gauge. Even the remote points, even the remote most areas rainfall can be measured by tipping buckets and most rugged operation is simplest. Which rain gauge is used to measure both rainfall and snowfall? Which rain gauge is useful to measure both rainfall and snowfall? Sometimes the question is asked. This is nothing but a weighing bucket rain gauge. So all the 3 recording type weighing bucket type rain gauge we are going to have. All the 3 types of recording type rain gauges have got individual specialities. Indian Meteorological Department has recommended siphon type rain gauge and remote most areas most accurately tipping bucket and most rugged one weighing bucket rain gauge. Which rain gauge will work based on Hooke's law? Your answer, weighing bucket rain gauge. Which of the following rain gauges will not give mass inflow curve as the output? Answer, tipping bucket. Tipping bucket will give hydrograph as the output. याद रखिएगा. Weighing bucket siphon will give mass inflow curve. Weighing bucket also will give mass inflow curve as the output. Accumulated rainfall versus time. What is mass inflow curve? The question may be asked. Mass inflow curve is a plot between dash. Answer, accumulated rainfall versus time. Cumulative rainfall versus time is the answer for that. So the output graphs also equally important, sir. For this mass inflow curve will be the outputs. For this hydrograph will be the outputs. The output graph is hydrograph. For this again mass inflow curve, popularly abbreviated as MIC. So which of the following rain gauges will not give mass inflow curve as the outputs? Your answer is tipping bucket. So, recording rain gauges, a question may be asked like this. If the optimum number of if the optimum number of rain gauges are capital N, minimum 10% of N must be of recording type. According to the Indian Standard Code observations, minimum 10% of capital N, 10% of capital N must be of recording type. At the maximum, 90% of N can be 90% of N can be non-recording type rain gauges. Because of cheap and easily accessible, everyone will prefer the non-recording type, and it is sufficient also. But to get higher accuracy in measuring the average depth of rainfall, it is better to, according to IS code provision, in any catchment area, minimum 10% of the rain gauges, total optimum number of rain gauges, minimum 10% must be of recording type. That too, siphon type is commonly preferred. IMD recommended recording type rain gauge is dash. Answer, siphon type rain gauge. Siphon type, also called float type. Float, a wooden scale is kept on the free surface of the collecting chamber. As the volume of the water goes on collectively accumulated, as the float is moving in the upward direction, the ordinate on the graph is going to be increasing, showing that mass inflow curve as the output graph. Please remember this point also, it is a very one important point. If a question may be given as ISO height and ISO NIF, ISO height, line joining the equal depths of rainfall, line joining equal depths of rainfall is called ISO height, and ISO NIF is equal depths of snowfall. The line or curve obtained, ISO NIF is the line or curve obtained by joining equal depths of snowfall. Equal depths of, what is the difference between ISO height and ISO NIF may be asked. You may be asked, what is ISO pleath? ISO pleath, line or curve obtained by joining the points of equal potential evapotranspiration values. Equal potential evapotranspiration values is called ISO pleath. It may be asked as ISO pluvial also. Question may be asked, what is ISO pluvial line? Pluvial, technical names, you must remember the spelling also. What do you mean by ISO pluvial lines? The question may be given. ISO pluvial lines are the lines joining the points of equal depths of rainfall in a given time interval with the same return period. ISO pluvial lines are obtained by joining the points of equal depths of rainfall in a given time interval all with the same return period. Such questions may be generally asked. Then, to calculate the average depth of rainfall, what is the most important method, most accurate method? Everyone knows isohydral method, commonly asked one. Which of the methods of calculation of average depth of rainfall will be assuming infinite number of rain gauge stations existing on the catchment? Answer, isohydral method. Isohyd can be drawn when you know the depths of rainfall at each and every point of the catchment. When can you know the each and every point's rainfall on the catchment? When I have so many number of rain gauge stations in the catchment. That's why if you are asked, the isohydral method is the most important one. Which one will give the most accurate value? The reason for being most accuracy, it assumes infinite number of infinite number of rain gauge stations are assumed to be existing on the catchment. Infinite number of rain gauge stations are assumed to be existing on the catchment. This area, the three methods, arithmetic mean method, Thesian polygon method, isohydral method, which method is having the drawback, in which method we got all the rain gauge stations should be within the catchment area only, not outside the boundary. Which method is going to have least accuracy? Answer, arithmetic mean method. What is the essential condition for the Thesian polygon method to be adopted? Thesian polygon method, the number of rain gauge stations can be outside or inside. But when we want to give the weightage to each and every rain gauge, that's why it's called weighted area method. What is the alternate name for Thesian polygon method? One of the question. What is the alternate name available for Thesian polygon method? Answer, weighted area method. Thesian polygon method, alternate name is weighted area method. You are able to get such questions very easily from precipitation. A question may be asked on DAD curve, depth, area, duration curve. The question asked will be of this type. For the given duration, if the catchment area increases, peak depth of rainfall, P max, is going to get decreased. For the given 1 day rainfall, 200 square kilometer catchment area will have 30 centimeter average depth of rainfall. For 2000 square kilometers catchment area, what will be the average depth of rainfall or peak rainfall depth? You can ask the answer. As area increases, peak depth of rainfall gets decreased. Answer, less than that. We cannot calculate. We cannot apply the equation. We cannot get a mathematical calculation of P is equal to P0 into e to the power of minus KT, Ka power n. This is the formula. We cannot get this numerical application of this formula in the exam. It will ask just with increase in catchment area for a given duration of the rainfall, what will happen to the maximum depth of precipitation? Answer, decreases. And for the given catchment area, here area, here depth of the precipitation, here duration. If you see, for the given area, 1 day rainfall, 2 day rainfall, 3 day rainfall. For the given area, as duration increases, if area remains constant, as duration increases, maximum depth of precipitation also will increase. Such DAD curves importance is important, sir. What is the use of the DAD curves? The question may be asked. These are the likely to be asked questions asked in examination. If a numerical problem is given, they will give most commonly in isohydral method. If there are three curves, this is isohyd 60, this is isohyd 70, this is isohyd 80. Area between them is A1, area between them is A2. A1 area is bounded by 60 and 70. So average depth of precipitation will be 60 plus 70 by 2. So this will have 65. 70, 80, this will have 75. So A1 into 65, A2 into 75 divided by A1 plus A2 will give the total average depth of rainfall. Application of isohydral method will be generally asked in the numerical calculations and also easy one. P1 plus P2 by 2, P1 plus P2 by 2 multiply with A1 plus P2 plus P3 by 2 multiply with A2 whole divided by A1 plus A2, you will get the value of P bar very easily from this. You may ask the definition of return period. It is the minimum time taken for a particular rainfall equal to or greater than, when I say the word P, equal to or greater than P, for a particular rainfall in brackets equal to or greater than, to occur once again in the catchment area. Define return period. The return period का definition पूछने का संभावना. He will give the entire definition. He will ask you what is that called as recurrence period or return period. When we want to have the statistical study of rainfalls at a given rain gauge station, this frequency distribution will be studied at a particular rain gauge station. That is called point rainfall. You may ask a question. What is meant by point rainfall? The rainfalls recorded, measured at a particular single rain gauge station is called as point rainfall. Frequency studies of rainfall will be studied with reference to a particular rain gauge station. That's why frequency distribution will be referred to point rainfall. Point rainfall, rainfall recorded by single rain gauge station. Now, return period definition, the minimum time taken for a particular rainfall equal to or greater than a particular rainfall to get occurred again at a given catchment area, T. If T is known, T के लिए formula most important n plus 1 divided by m. Don't forget this Weibel's formula. Which method is the most commonly adopted to calculate the return period? Answer is Weibel's formula. T is equal to n plus 1 divided by m. N is the number of years of data available to you. Number of average annual rainfalls at that particular rain gauge station available, capital N. Whatever rainfall is referred to you, what is the rank of that rainfall in that, when you write all the values in the decreasing order, you are going to get the Weibel's formula to calculate the return period. Once I know return period, probability of success of the event will be 1 by T. Probability of the failure of the event is equal to 1 minus P, 1 minus 1 by T. Once you know this, then probability to get the required rainfall, probability not to get the required rainfall, 4-5 cases are there. That much question may not be given, but have a glance about the 5 cases. Most common, most important one is probability of getting a particular rainfall at least once is important in the coming n years. आने वाले n सालों में at least एक ना एक बार, at least once to get the rainfall, what is the chance? Your formula is 1 minus q power n. Percentage wise you have to multiply with 100. Its value is 1 minus q power n formula, where q is equal to, we know that pretty well, 1 minus p, 1 minus 1 by t. So this is given by 1 minus 1 by t whole to the power of n is the formula. Numerical problem is impossible to be asked. Numerical problem cannot be asked on this. Pucha gaya to formula will be asked, or otherwise which of the following expressions in the standard notation, which of the following formula will give you the probability of getting a particular rainfall at least once in the coming x years, n years, t years, like that. Some different symbols may be used to confuse us. Don't get worried, formula is very standard one. 1 minus q power n formula. What is the probability of getting a rainfall? Probability of getting a rainfall not even once. So it's a complementary. So it's the probability of x is equal to 0. Q power n is the formula we get. Probability of getting a rainfall not even once, q power n, at least once complementary of that 1 minus q power n, 1 minus q power n probability of getting a particular rainfall at least once. These particular formats are important in the probability distribution. When we see the evaporation, pan evapometer में क्वेश्चन पूछा सकता है. Pan evaporation, United States Weather Bureau, Class A pan, coefficient of pan will be 0.7, we know CP value, E water body divided by E pan, rate of evaporation of the water body is equal to Cp into E pan. We do the experiment on the pan constructed by the side of the, on the bank of the water body. If it is the river, on the bank of the river, if it is the reservoir, on the bank of the reservoir. From whatever water body you want to calculate the rate of evaporation. From that we are able to calculate E pan multiply the Cp will give E water body. Rate of evaporation from the water body we can calculate. So for that Cp value, United States Weather Bureau, Indian Standard Weather Bureau Class A pan, Cp value 0.8. Once you get Cp value से E water body आ गया तो from the field you get E pan, E water body is equal to E water body is equal to Cp into E pan, Q water body is equal to area into E water body, area into Cp into E pan. E pan फार्मूला आपको पता हो जाए, मालूम ही होगा P प्लस आर माइनस जेड, रेनफॉल प्लस आर माइनस डेप्थ ऑफ द वाटर एडेड, प्लस साइन ऐड करने के लिए माइनस साइन व्हेन द वाटर इज रिमूव्ड फ्रॉम द पैन. And if you want to calculate how much water of the water has been evaporated, discharge evaporated into time of reference. These formulas are worth remembering. What is the most commonly adopted pan? Answer: United States Weather Bureau or Indian Standard Weather Bureau. Remaining two are not important. Flow type and second one is the flow type and the second one is the buried type. These two are not necessary. Geotechnical Society. So these two are important. Cp value US के लिए somewhat less, Indian Standard के लिए 0.8 याद करो, 0.7, 0.8 याद रखना होगा. To calculate the rate of evaporation, everyone knows what is evaporation. Volume of the water evaporated divided by surface area of the water body multiply with the time of reference of evaporation. Time of evaporation. Volume by surface area will give the depth of the water evaporated per unit time, mm per hour, mm per day, like that we get. So what factors are going, there is also very important area where we got the, we can, if you refer to the standard procedure, standard points, there are about 7 to 10 important points. Most important is the quality of the water. With the increase in the quality of the water, rate of evaporation increases. With increase in impurities, the rate of evaporation decreases. Rate of evaporation in sea, ocean is lesser than the rate of evaporation in river. River will have greater rate of evaporation. Such logical questions will be asked in the RRB examination. Then what are the methods available? First method I told you, the pan evapometer method. Second one is empirical formula, that too most commonly Mayer's method. By applying the conservation of mass, we use the third method, mass budget method. Sum of the inflow minus sum of the outflow is equal to A into delta S by delta T formula. Sum of the inflows to the water body, sum of the outflows for the water body. Inflow minus outflow is equal to change in storage. To make it dimensionally homogeneous, by writing all the values you can get the rate of evaporation. Somewhere in the sigma O you will get the rate of evaporation. So you can get that formula also very easily. Then the fourth one is conservation of energy principle. by means of conservation of energy principle, also called energy balance method, we get the formula for rate of evaporation is equal to solar heat energy divided by density of water into latent heat of vaporization. This is also a valid formula to calculate the rate of evaporation. This may be a question because these two are constant, 1000 kg per meter cube, 540 into 4200 SI units. These two are known. अगर आपको solar heat energy का constant दिया गया तो you can calculate the rate of evaporation from that water body on that day when you know the solar energy, you can calculate heat energy radiated. When I know, I can get the values very easily from this. Is also one important area where in RRB examination a question will be asked. Then transpiration and evapotranspiration. Evapotranspiration is asked based on moisture content. Which of the following losses will depend upon the moisture content of the soil? Answer: moisture content will decide potential evapotranspiration and actual evapotranspiration. When the moisture content is equal to permanent wilting point, there is no water available, so your AET value becomes 0. As the moisture content increases and MC becomes FC, your actual evapotranspiration will become potential evapotranspiration. Very, very important point, remember this. With increase in moisture content, what will happen to with increase in the moisture content of the soil catchment area, what will happen to the rate of evapotranspiration? Answer: it increases from 0 to maximum value. At what temperature AET will be 0? Answer: permanent wilting point. At what moisture content AET will become equal to PET? Answer: field capacity. बीच में MC is equal to OMC भी आएगा. So these values you should remember regarding potential evapotranspiration. To calculate the potential evapotranspiration, which formula is commonly used? Blaney-Criddle formula. Blaney-Criddle formula is commonly used. Such formulas also don't forget, and it's a mathematical calculation also you should remember. Then regarding the runoff, in the chapter of runoff, simple formula R is equal K into P. R is the runoff depth, P is the rainfall depth, K is called runoff coefficient. Cement concrete road, K value 0.9, 0.95. Tar road 0.8. Kacha road 0.6, forest ho to 0.3. Depending upon the nature of the catchment, ज़्यादा vegetation हो तो runoff will be less. ज़्यादा vegetation हो तो more water will be stopped by the plants, then runoff will be less. Absorption of the water by the soil is more when there is more vegetation. If it is a dry land and steep land, we can get the value of runoff with higher values of that. Such questions also very, very important. एक बार एग्जाम में दिया गया, there is a catchment area, A1, A2 areas, it is 60%, it is 40%. It's a K value 0.7, it's a K value 0.5. What is the average runoff coefficient? K1 A1, simple formula. K1 average means numerical average. K1 A1 plus K2 A2 divided by A1 plus A2 formula we can get 60%, 0.6 into 0.7, 40%, 0.4 into 0.5 divided by 0.6 plus 0.4, answer is 1. It is 0.42, that is 0.2. Total average runoff coefficient of the entire catchment area will be one important formula in the runoff chapter. When different parts of the catchment has got different runoff coefficients. Different parts of the catchment are having different runoff coefficients. K1 A1 plus K2 A2 plus K3 A3 whole divided by A1 plus A2 plus A3 will give you average value of runoff coefficient of the entire catchment. From the runoff, hydrographs are important, as you know. It is the flood hydrograph, you must know. Flood hydrograph will be including the base flow, Runoff discharge, define hydrograph. Define hydrograph, runoff discharge versus time. If it includes base flow, the water which is not visible, the water flowing at deeper beds of the catchment area, unmeasurable, cannot be seen, that is called base flow. Then it is called flood hydrograph. Hydrograph is the graph drawn between discharge and time. Hydrograph, first chapter hydrograph, we did not mention. Name is mentioned, but we did not see what is hydrograph. Intensity of rainfall versus time. Area of the hydrograph gives dash, depth of the precipitation. Area of the hydrograph gives dash. Area of the hydrograph gives dash, volume of the runoff. Volume of the direct runoff. The question may be asked, what is the area of the, see, if you from the flood hydrograph, if you remove the base flow, you will get a direct runoff hydrograph. Direct runoff hydrograph is given by dash. Answer, by subtracting the base flow from the flood hydrograph. By subtracting the base flow from the flood hydrograph, we can get flood hydrograph minus base flow will give direct runoff hydrograph. Then what is the use of the S-curve hydrograph? When the rainfall duration is extending to infinity, you are going to get a stage of equilibrium. Formula may be asked, QP formula 2.778 A by D, A in kilometer square, D in hours and QP in meter cube per second. By taking all the conversion factors into account, this format has come. Don't forget QP is in cubic, A is in square kilometers, D will be the duration of the rainfall, initially taken as the unit rainfall duration, D hours. Then its importance of unit hydrograph. To get the ordinates of unit hydrograph, direct runoff hydrograph divided by R value. R is called direct runoff depth. How do you get the procedure? How do you calculate the direct runoff depth? Area of the DRH divided by catchment area. It is also one question given in the previous RRB examination. Once you get from the flood hydrograph minus base flow, you will get the direct runoff hydrograph. Direct runoff hydrograph divided by area, it's the area of the direct runoff hydrograph by area of the catchment, will give DRO depth capital R. Dividing each and every OI, UI, any particular ordinate of direct runoff hydrograph divided with R, you will get the corresponding ordinate of unit hydrograph at that instant of time. Such questions will be asked in the examination. What is the hydrograph, and then what are the, if the duration of the rainfall increases, what will happen to base period? Such questions also. Without changing I, if D1 increases to D2, B1 increases to B2. So your B2 formula will be B1 plus D2 minus D1 is the formula we get. Formula for B2 is equal B1 plus D2 minus D1. So difference of the base periods. Base period is nothing but duration of the rainfall, everyone knows. Difference of the base periods of two runoffs is equal to difference of the durations of two corresponding rainfalls. A very important formula. B2 minus B1 is equal to D2 minus D1 formula we get. Then flood routing and such chapters are not that much important. Well hydraulics mein kabhi almost alternate times they are asking questions. Well hydraulics, you must know the definitions of aquifer, high porosity and high permeability, then aquitard, then aquiclude, clay. This is best example, sand deposits. This is sandy clay or clayey sand. This is clay. Then rock is aquifuse. Fuse, it refuses everything. It can't store water, it can't transmit water. Examples of these four geological configurations you must remember: high N value, high K value, moderate N value, less K value. K value almost 0, N value is moderate. Here N0, K0. Rock is the example. Which of the following will be referred to the example of rock? Answer, aquifers. Neither able to store the water nor able to transmit the water. Able to store the water, unable to transmit the water. Able to store water, small quantities, able to transmit water, small quantities. Able to store large amounts of water, can deliver also large amounts. Sand deposits is the best example for aquifers. You must know the difference between confined aquifer, unconfined aquifer, specific yield, specific retention, both are equal to porosity is a very important relation. Porosity of a aquifer is equal to sum of the two parameters. One is the specific yield, second one is the specific retention. These two points are very important in the groundwater hydrology. What is the formula for permeability? As that of velocity. Permeability depends on two factors: soil properties and the water properties. If it is only soil property, then it is intrinsic permeability. That also question may be asked. Which permeability will be depending exclusively on the soil properties of the catchment? Your answer will be intrinsic permeability is the right answer. Intrinsic permeability. Remaining chapters, flood routing, just if you have the time you can read. These are the generally asked questions in the hydrology subject. Let us see some important questions on irrigation also, because time given is 1 hour. Already the time is almost 40 minutes is over. Let us have a brief revision of the water requirement of crops. In the water requirement of crops, most important questions: what is the water application efficiency? Q transfer to the plant divided by Q transfer to the field. Water conveyance efficiency, Q transfer to the field divided by Q supply to the canal system. If you multiply these two, you will get overall efficiency. Overall efficiency is the product of application efficiency and conveyance efficiency. Application efficiency will indicate the losses of water in the field by the time it reaches the plant, and the conveyance efficiency will indicate the losses in the conveyance system, that is main canal, branch canal, major distributor, minor distributor and field channel. They are important formulas. The relation between duty delta and base period. In SI system, delta is equal to 8.64 B by D. Delta is the depth of the water required to get the plant completely matured in meters. B is the total duration of the crop, within what time the water supply will be totally over, whatever water is required to be delivered to the crop in order to get it to maturity. What's the time available? Time interval between first watering to the last watering is called base period. Time interval between first watering to last watering is called base period. D is the duty of the water. Duty of the water is given by duty, not the person, duty of the water. Area actually irrigated by discharge. This definition is very important. SI system में 864 B by D. This delta will be in centimeter. These questions may be asked on this also. Efficiencies and delta values. Then as we move from the source to field, Q will decrease, duty will increase. Very, very important point. As the water progress, which of the following parameter of water requirement of crops will get increased as water travels from source to destination? Discharge will decrease because of consecutive losses. Depth of the water available less, volume of the water available less. Time period goes on decreasing, and only one increasing is duty of water, because area by discharge. As discharge goes on decreasing, area remains constant. Constant value by decreasing value, automatically increasing value. Which parameter will have increase in value as water travels from source to destination? Answer duty. Answer duty. Duty of the water is very, very important. Examples of Rabi crop you must know. Examples of Kharif crop. Rabi, remember OMR. October to March Rabi season. October to March Rabi season 6 months, but actually 4 months. Kharif season crops examples rice. Like that you can remember. Kharif season ASK. April to September Kharif. April, May, June, July, August, September 6 months. Theoretically 6 months, practically 4 months. So Kharif season rice and Rabi season wheat, most common examples. Only naam ke vaste those examples are given. Main purpose, if we have the land of sufficient strength, land to get irrigated, land with sufficient soil strength, and if you are able to get the water delivered to the plant, whatever delta value is needed for the crop, if you are able to get the water supplied, more than sufficient. These are only just for naam ke vaste. Summer season crops are called jade crops. What is the, एक बार पूछा गया या IES examination में, what is the season of, what is the duration of the jade crops? Answer 2 months. Peak summer 2 months, generally April 12th to June 12th. April 15th to June 15th. Then what is paleo watering? It is the first watering given before the sowing operation to make the land ready for cultivation, to keep the soil in the field as a three-phase system. How much, whatever water we are supplying to the field, that is called paleo watering. Then one more question is likely to be asked, core watering. This type of questions also पूछा जाने का संभावना है. What is meant by core watering? It is the second watering given to the land, first watering given to the crop. Sowing के बाद जो कुछ water पहली बार दिया जाता है, that is called core watering. So paleo watering and core watering both are important definitions in the water requirement of crops. Water requirement of crops. Intensity of irrigation. Intensity I is equal total area actually irrigated by total area fit for irrigation. Area is the one important definition. I can be calculated for Rabi season. I can be calculated for Kharif season. Total I is equal to I Rabi plus I Kharif plus अगर third season का crop हो तो I jade. This is one of the important formula we can get in the water requirement of crops. Then we see methods of irrigation में कभी कभी पूछा जाता है, which of the following is the most important essentiality to adopt sprinkler irrigation when the area is having water scarcity. When the area is having water scarcity, there is no other go. You have to go for sprinkler irrigation with the limited water. Maximum area should be made wet. Necessary water can be delivered by sprinkling water on the plant's leaves so that efficiency of irrigation will get increased. What is meant by drip irrigation? What is the difference between drip irrigation and trickle irrigation? What is meant by furrow? One of the SSC JE examination question may be asked in RRB also. What is meant by furrow? Furrow is a small open channel constructed within the field in order to deliver the water laterally below the ground level, furrow irrigation. Such questions are important. Questions will be asked on the moisture contents of the soil is very important. Saturation capacity, field capacity, optimum moisture content, temporary wilting point, permanent wilting point, ultimate wilting point. This area is also very important for RRB. What is gravitational water? The water which is undesirable for the crop growth. The water which is undesirable for the plant's growth, that is called gravitational water. It's the water that should be drained out at any cost. Water, that is the water available between saturation capacity and field capacity. What is the water content useful for the plant's growth? Field capacity to permanent wilting point, that is called capillary water. Define capillary water. It is the water meant for plant's growth. It's the water meant for plant's growth. बहुत आसानी से पानी दिया गया तो फील्ड कैपेसिटी टू OMC, थोड़ा तकलीफ से दिया गया तो OMC टू TWP, बहुत मेहनत करके ज़्यादा तकलीफ से खेत को पानी दिया गया तो TWP to PWP. At what moment plant will die instantaneously if the water is not supplied? One of the question. Answer. Permanent wilting point. At what moisture content of the soil plant will die instantaneously if we cannot deliver external water? Answer is permanent wilting point. At permanent wilting point, if the farmer is able to get the water at least in the buckets, plant will survive for a few more days. More than 4 or 5 times in different competitive examinations of various levels, this question is asked on permanent wilting point. The water between permanent wilting point and ultimate wilting point is called, this is the water inextractable to the plant. Which of the following waters cannot be extracted by the plant at any cost, even we apply the greatest pressure of the order of 40 to 50 to 60 kilopascal. Very high pressure, soil moisture tension is very high, still plant cannot get single drop of water in what moisture content zone? Your answer is between permanent wilting point and ultimate wilting point. This water is called hygroscopic water. My dear aspirants, please remember the 6 moisture contents and also the 3 types of soil water. Gravitational water के बारे में पूछा सकता है और capillary water and also hygroscopic water. All 3 waters are equally important. When we go for the design of lines, अगला chapter ध्यान देना चाहिए about design of unlined canals. Design of unlined canals always trapezoidal cross section. Always. Unlined canals are always unlined canals. Trapezoidal cross section. No other shape is permitted. Side slope is always fixed, half horizontal to 1 vertical. Standard area for area, standard formula for area of the cross section of the unlined canal. Area is equal to BD plus D square by 2. What is the formula for wetted perimeter? B plus D root 5, B plus 2.236 times D. These 2 formulas are also standard formulas. You must remember these regarding unlined canals. There are 3 theories available. Theory 1, Kennedy's theory. Kennedy's critical velocity is given by 0.55 m d power 0.64. Second one is the Garrett's theory. Garrett's theory is a graphical theory. And the third one is Lacey's theory. As on today, design of unlined canals are based on Lacey's theory. Lacey's non-silting, non-scouring theory. Non-silting, non-scouring doesn't mean no silt, no scour. That is called state of equilibrium, called regime theory. What do you mean by regime condition? It's the condition of equilibrium. It's the condition of equilibrium. Whatever water is coming from upstream, whatever is the silt load coming along with the water, the same silt load should be transported to the downstream side. It means status of regime, status of equilibrium, status of non-silting, non-scouring condition. Status of non-silting, non-scouring condition. This is what we have to remember. Regarding the regime, Lacey's regime condition, you must know what is initial regime. when B and D are fixed, longitudinal bed slope is not yet finalized. That intermediate stage of design is called initial design. When all the three dimensions, what are the three output parameters of unlined canal? Unlined canal in alluvial soil. What are the three output parameters? We should remember bed width and depth and bed slope. If all the three are fixed up, the canal design is said to be in the state of final design. Lacy's equations are important. V is equal QF square by 140 whole power 1 by 6. It is one of the previous RRB examination. The formula for wetted perimeter is equal 4.75 root Q. एक बार वन एग्जाम में पूछा गया, my dear friends, when the discharge is increased by 125%, wetted perimeter increased by dash percent, a question is asked. Simple question, P1 by P2 is equal square root of Q1 by Q2. P1 is 100, P2 is unknown. Q1 is 100, Q increase gaya 125. 100 plus 125, 225. Root 100 is 10, root 225 is 15. 100 by P2 is equal 10 by 15. This is 100 times P2 becomes 150. 100 बन गया 140 हम 50. Therefore, wetted perimeter increased by what percentage beta? 50% is the answer. Questions on Lacy's enzyme theory are important. Are important for us. Regarding the diversion headworks, questions will be asked. What is the difference between weir and barrage? What is meant by piping failure? What are the three theories available regarding the design of diversion headworks? One is Bly's theory, second one is the Lane's theory, third one is the Kosla's theory. What is the most reliable one? Kosla's theory, most rational, scientific. Which theory is based on flow net analysis? Your answer for the question is Kosla's theory. If the downstream pile is not provided, what will happen to the exit gradient? Answer becomes infinity. Exit gradient becomes infinity means practically such a weir will not exist in the reality. That's why essentially which of the following is the most important component in a diversion headwork? Answer, downstream pile is the most important one. Downstream pile, to keep the weir protected from the piping failure. Then regarding the gravity dams, just go through the different forces, water force, and then seismic force, then silt pressure force, wave pressure force. Then the four possible failures also important: sliding failure, overturning failure, compression failure, and tension failure. These four failures are important. What are the factors of safety also you must remember. These are some of the questions. Actually, because of lack of time we are not able to cover that much. Still, I have tried my level best to give the most important areas and the most important questions in the subjects of hydrology irrigation. Once again, I wish you all the best regarding the RRB examination. Good luck, my dear friends. సంతోష్ లేడా